Hello, today I'm looking at M3 International A Level January 2014. This is question 6. I have this enormous diagram which I'll just let you look at for a second. Okay, so it says a light inextensible string of length 14A has its ends attached to two fixed points A and B. So A is up here and B is down there, where A is vertically above B and AB is 10A. Okay, a particle of mass m is attached to the string at point P where AP is 8A. So if they said the string was 14A, then this part will be 14A minus 8A, which is 6A. The particle moves in a horizontal circle with constant angular speed omega, and both parts of the string are taut, as shown in figure 3. Show that the angle APB is 90 degrees, and then show that the time for the particle to make one complete revolution is less than this. Okay, so if I begin with the triangle, then I know that this is 10A, I know that this is 8A, and I know that this is 6A because I did 14A minus 8A to get this. So okay, theta equals 90 degrees if 8A squared plus 6A squared equals 10A all squared, using Pythagoras' theorem. So if I look at the left hand side, then I get 64A squared plus 36A squared, which is 100A squared. If I look at the right hand side, then I get 100A squared, and so then I need to say left hand side equals right hand side, therefore the angle, what was it called, APB, is 90 degrees. Okay, so that's the first part of the question. Then in the second part of the question, when they ask me these things about the time for the particle to make a complete revolution, really they're asking me for omega, because I need to use this, that the time is 2 pi over omega, and so I need an equation with omega in it. So what I need to do is look first of all at what's going on with the forces acting on P. So I've got the weight, mg, I've got this tension, which I'll call TB, I've got this tension, which I'll call TA, and let's just pop in some dotted lines here. Let's call this angle alpha, and I can use this triangle here to work out what alpha is. So alpha would be here, and so using alternate angles, this angle is alpha. And I know that this angle APB is 90 degrees, so therefore I know that sine alpha would be the opposite over the hypotenuse, so 6A over 10A. So the A's will cancel, 6 over 10 simplifies to 3/5. And I know that cos alpha would be the adjacent divided by the hypotenuse, so again the A's cancel, and 8 and 10 divide, can each be divided by 2, so I end up with 4/5. Okay, I'm working out these so that when I do all of my resolving, then I've got the nice values for sine alpha and cos alpha, so I don't have to keep writing them out over and over again. This is alpha, that's not alpha, this is alpha. I know that these two angles add up to 90. I also know these two angles add up to 90, so this angle here is alpha as well. Now, the only other thing that will happen to P, other than these forces, is that there will be an acceleration towards the centre of the circle. So whenever I'm doing an acceleration question for a circle acceleration question, I can use r omega squared or v squared over r. And in this case, because I'm interested in omega so that I can get to this, then I'll use this and not that one. So I need the radius of the circle in which the particle is moving. So in this case, I need this length here. So So the radius of the circle will be 8a, which is the hypotenuse of this, multiplied by sine of alpha. And so I get 8a multiplied by 3/5. So I get 24a over 5 is the radius. So therefore the acceleration here will be the radius times omega squared. Okay, so now I'm ready to begin resolving. So if I resolve vertically, then I get TA cos alpha equals mg plus TB sine alpha. And now I can pop in the values of sine alpha and cos alpha. Cos alpha is 4/5, so here I get TA times 4/5 equals mg plus TB times sine alpha, which was 3/5. Okay, I'll multiply everything by 5 just to get rid of all these fractions. Hopefully that will be useful later on. So I get 4TA equals 5mg plus 3tb. Okay, so let's just call that equation 1. Now if I resolve in this direction, because then I can get an equation with omega squared in it, and so resolving horizontally, I get TA sine alpha plus TB cos alpha equals the mass times by the acceleration. Okay, so popping in the values for sine alpha and cos alpha. Sine alpha was 3/5, so I get 3/5 TA plus cos alpha was 4/5, so 4 TB over 5 equals 24 over 5 MA omega squared. And all of these are divided by 5, so I could just tidy this up by multiplying everything by 5. Okay, so let's call this equation 2. Now, okay, so having done all of that, that is going to get me a lot of marks so far. But in order to end up with this limit on t, because they said that t would be less than or equal to something, yes, would be less than or equal to something, then I basically need to show that omega will be bigger than or equal to something. So how do I get an inequality with omega in it? Well, it's going to come from what is going to happen to this part of the string if omega is not big enough. So if omega is too low, then it will mean that the string goes slack, and it will be TB that goes slack before TA would have any. So TA will always be there, and the upper part of the string will always be taut, but this part of the string that's down here could go slack if this is not going basically fast enough. So I'm going to work out what TB is and then say that TB needs to be bigger than or equal to 0, and therefore I'll get an inequality to pop into here, and so I'll essentially get an inequality for t. Okay, so I need to therefore eliminate TA. So if I multiply this one by 3, and so that I get 12 TA, I'll multiply this one by 4, so that I get, again, 12 TA. Then let's see what that gives me. So I get 12 TA equals 15 mg plus 9 TB. And this one here, multiplying this by 4, I get 12 TA. I'm going to move this onto the other side, so I'm going to take 4 TB from both sides. So here I've got 24 times 4, which is 96 MA omega squared, minus 4 TB becomes 4 times 4, 16 TB. So let's call this 3, let's call this 4, and now I'm going to do 3 take away 4. So 3 minus 4 gives me that minus that, nothing. 15 mg plus, then I've got 9 TB minus negative 16 TB, so 9 plus 16 is 5, sorry, TB, minus this 96 MA omega squared. So rearranging this to give you TB, let's pop this over here. So I've got 96 MA omega squared minus 15 mg over 25 gives me what TB, an expression for TB. Okay, so as I said, now I need to get an inequality for omega, and so I'm going to get that by saying that TB needs to be bigger than or equal to 0. Therefore, basically the top of this will be bigger than or equal to 0. So I've got 96 MA omega squared minus 15 mg is bigger than or equal to 0. I could divide both of these by m, divide everything by m, sorry, because m is positive, that will have no effect on this. I could add 15g to both sides. I could then, to get omega squared on its own, divide by 96a. And to get omega, I then take the square root, and 15 over 96 can simplify to 5 over 32. So I've got 5g over 32a. And so that's the limit for omega. So then I'm using that formula that time period is 2 pi over omega. Therefore, t is less than or equal to 2 pi divided by this. And so to divide by this, I will multiply by the reciprocal. So the 32a ends up on the top, and the 5g ends up on the bottom. Okay, so I'll just compare that to what they said the value should be. So here they said, show that the time for the particle is less than this. So in fact, yes, time period is less than or equal to 2 pi, and then I've got exactly the same expression that they did, fortunately. Hurrah! Okay, so that part of the question was worth 13 marks. You've also got the 2 marks from before, so overall you've got 15 marks. I hope you found that solution helpful. Do click like if you liked it, and good luck with your studies.